Awesome. And yeah, feel free to like ask any questions in between. Welcome everyone to the embedded meetup, and nice to see new faces around. Feel free to turn on your video or not. And just want to introduce myself and also Wellington. So my name is Binal. I'm hosting this meetups. I started like late last year as I was looking for some meetup kind of culture in Bay Area and didn't find much. So I thought like let's start this. It's been mostly in person so far, and there had been a few requests of people asking for kind of hybrid and having an option to join virtually. So this time we are trying virtual, as well as Wellington is also joining from Brazil. So we wanted to make that happen. So thanks a lot for joining like at a late time for you. I think it's like what 10 p.m. or something uh, over there. So really
Yep.
appreciate you spending that time with us. And so, just a little about Wellington. He is at PX5. He's a director at PX5, and we have a history of working together at Microsoft as part of IoT. So we worked on device SDKs together for a couple of years, and that's how I know him. So very nice to see you, Wellington, and yeah, let's get started.
Of course. Yeah, nice to hear you too, yeah, and thanks again for the invite. Today, I'll be talking about some of the RTOS challenges, some technical, non-technical ones, mostly from my career working with RTOSs. And you will see that I'm pretty limited with the amount or the variety of RTOSs that I'm going to be covering today. But feel free to stop me and ask for ask any questions you have. Okay. So let me start with the context. So as Bino said, I used to be a Microsoft employee, and now I work at PX5 RTOS, so it's a startup company. It's really interesting to see how the mindset has to shift, right? Because at Microsoft, RTOS was an enabler of a bigger business, in this case, Azure. And right now, RTOS for me is the main attraction. Before I was selling adoption, so cloud adoption, and everything we were doing at Microsoft IoT was to sell adoption to Azure. And for me now is to actually selling the RTOS. And finally, yeah, we, back in the day, we used to work at mostly at the user guidance, and doing some evangelism. And really now the fact that we need to do super deep dive. But I thought of sharing with you because this might not many people might know is the fact that so the history, right, of ThreadX. And so ThreadX was a product created by this company called Express Logic that was acquired by Microsoft. So Microsoft bought ThreadX and they rebranded as Azure RTOS. So every time you hear Azure RTOS is nothing but ThreadX through an acquisition, right? And then I worked with Azure RTOS as Binal did during for a couple of years, right? And so Microsoft did a lot to improve ThreadX. But then what happened a couple of months ago, Microsoft decided that this is not something they want to pursue anymore. And this was open sourced. So everything ThreadX was, plus maybe 3 years of improvement from Microsoft organization, is now open source as the Eclipse ThreadX, which is a pretty nice RTOS, as you might imagine. And the folks who actually built and wrote ThreadX, they moved to Azure to Microsoft, and then they left Microsoft to start PX5 RTOS. So actually, this all of these has pretty much the same line in which we have a new kid on the block, PX5 RTOS, but also ThreadX now as an open source product, which is a pretty nice addition to the open source community. Now, keep moving. So, of course, ThreadX is not the only one. When we think about the RTOS landscape, right? And I'm looking at this list with two different perspectives. The first one is for me as an employee at an RTOS firm. These are my competitors. But for you guys working with embedded as a customer, these are your options as a customer, right? And according to the latest of those embedded researches. What we saw here in terms of RTOS was, of course, free RTOS backed by Amazon being, the number one RTOS out there, followed by Kyle, and then you see ThreadX as ThreadX to this day here on the list, which is a pretty nice one. Texas Instruments, RTOS, QNX, Freescale, Micrium, VxWorks, and so many others, right? So this is all of the list of RTOSes that you might choose. But of course, choosing one or the other is always a matter of looking at trade-offs and looking at what are the features you need, what is your budget, can you pay for a license or not, how good is your software development team, which means can you afford doing maintenance, and or do you need a license support contract, right? And how much support do you anticipate needing? So first thing to consider in this RTOS landscape is there are plenty of choices, but also a lot of things you need to think about before choosing one or the other. And then following on the RTOS landscape, right? So we talked about a bunch of these. So the feature set, certifications, compatibility, royalties, support, and any differentiators. But let me tell you for a second, on what are the things that we are doing at PX5 RTOS, right? When it comes to feature set, in which in this case we're fully, full RTOS feature set, which means, yeah, we have pretty much everything all of the other RTOSs out there have as well. I have a different slide to talk about safety certification, so I'll hold on that. When it comes to compatibility, that's also pretty important. And in this case, PX5 RTOS, is POSIX APIs compliant, which means that if you're already familiar, with Linux embedded, moving to an RTOS like this would be pretty simple. There's no royalties when you use free RTOS. Oh, sorry, PX5 RTOS. And then uh, support, of course, there is support because this is not an open source, so there is support for that, but also for ThreadX. So if you don't have the budget to get into PX5 RTOS and you're considering perhaps using ThreadX, which is now open source, you could still buy support from these people who, again, right, as I said before, were the ones who created ThreadX in the first place, right? There's a bunch of other differentiators in terms of, POSIX compatibility, the size and pointer data verification. There are many other aspects to consider. But one that customers are really looking to get, and this is becoming more and more important as customers are using RTOSs like this in more critical applications, that will be the functional certification. So just to give you a bit of background of what that means and what that is, right? So um, first question you need to ask yourself is which one do you need, right? Because there are plenty of different ones. There is this one for industrial machinery, another one for medical equipment, automotive, rail industry. And of course, the ISO 26262 is the most famous of all of them because of, the amount of embedded systems that we have in automotive, right? So first one is to figure out which one do you need. But the second one that's almost as important is which level do you need? Because all of these, they have 3 or 4 different levels of certification you can achieve, right? So in this case here, SIL 4, Class C, ACUD, and SIL 4 are the highest ones, which means any application must be certified to these levels, right, before you can get a certification like this, right? And what does being certified actually means? Well, it means for the highest levels, it means that you have to have 100% test coverage, that you need 100% test decision and branch coverage. You need to have a verified software development lifecycle. You'll need to have, safety manual and a safety documentations, and you need to keep that update to any minor change you do to your software. Then, of course, the first time you're certifying, it's a big, a lot of work, a lot of things you need to do. Then, of course, every minor change you do, it's less and less complicated to get the certification up to date, but something that you need to consider for the long run. Now, um, if you're thinking of getting a software there, an RTOS that is functional certified, then of course PX5 RTOS is certified in all of that. But hey, this is not open source. If you're looking for an open source, ThreadX is still certified. Yeah, indeed, they're certified. Their version 6.1 was certified, is still certified. That certification doesn't go away if you're sticking to that 6.1 version. But that's getting pretty outdated. This is 4+ years old. So, and until we see Eclipse Foundation, funding a new round of functional certification, if you want to use a version that is certified, 6.1 it is. But not all application will need to need a functional certification. But you know what? It's pretty nice to have one that it is, even if you don't need it to be certified, because being certified mean that there's a lot of testing, there's a lot of procedure behind all lines of code that goes into that product. So you're getting the advantage, you're getting all of the benefits from the certification, even if you don't need one, right? So this is for functional certification. The other thing, the other challenge that we see over and over is with, porting the RTOS to different platforms, and things like, Cortex M0, M4s, M7. So thinking of MCUs, but not only those, right? There are customers using Cortex A, which are much more powerful devices, customers using or looking to use ARM Trust Zone, and then, of course, the multi-core customers looking to get, either an SMP or MP solutions, and so, and just as a quick reminder, right, when we're thinking about multi-core, AMP, right, or asymmetric multi-processing means that I have multiple cores, right, but I might have a different RTOS or a different operating system for different cores, right? And I've seen customers using things like Linux, right? So imagine that they're using a Cortex A device. So they're running Linux in several of their cores. And for one of the cores, the one they need to take care of real-time application, then they have an RTOS there. And of course, we have samples for scenarios like this. And there's always the case of symmetric multiprocessing. In that case, I have only one instance of an RTOS taking care of all of the available cores. So having this kind of different architectures and different samples is always a challenge, and we're always running after getting the most of it. And as a customer, you want to make sure that the platform you're using is already covered with a port and is already covered with a sample, because otherwise this might be pretty tricky for you to get. Now, in some extreme cases, this will happen. You will be in a scenario where there's no porting to your platform. And in this case, you might be wondering, okay, so if I don't have a sample for the platform or the architecture that I want, what is how hard it is to get it working in my platform. So in this case, and here I have how we do at PX5, how do we get samples working for different platforms. And in this case here, I'm showing you how do we get started with, say, an STM32 Cube IDE or an IAR based project. So we start with a working sample, even if it is a blinky sample, right, for some of these devices. And then we add the PX5 RTOS source files. We need to do some modifications on the startup file, on the linker file, and the interrupt file. And I'm showing you in a second why we do that. And then we just add whichever sample PX5 RTOS sample I want, and voila, I get it working, right? But there's also what is not explained here is for you to make sure that whichever RTOS you're using, you have a proper documentation showing you how to do that. Because, of course, if you have documentation, you can follow. This should be simple. Boy, if you don't, that's a pain. So let me show you really quickly here, because I know we're on
So,
time here.
Wellington,
Go ahead.
kind of curious to know like the
Hmm,
symmetric versus asymmetric model that you showed.
hmm.
Like, what's the kind of like in the market, like what is used more, or is it just if there's any data around it that you've seen?
That's a great question. I can tell you, not from research, but from my experience in talking to customers, is that customers using MCUs, right? So lower level Cortex M0s, M4s, and M7s, most of the time they're using symmetric because they only want one instance of the RTOS taking care of the multiple cores they might have, 2 or 4 different architecture like this. And most of the time, or not, if not all the time, when thinking about Cortex A type of devices, the more powerful ones, right? They would be doing exactly as I said. They will have multiple cores running on Linux, right? Doing whatever the device needs to do. But then for the very specific part, they need real time, and that for the ones they have, hard deadlines and dealing with interrupts and things like that, then they have a separate core running an RTOS to take care of that. So it's pretty much like this. Of course, nothing prevents you from using, an architecture like ASP on an MCU. And I saw that, take there is this STM Age 7, which has 2 cores. One is an M7, one is an M4. And I saw that running, with a different RTOS for each one of the cores. So you can use, whichever, but most of the time this will be it. Cool. So yeah, back to porting, right? So let me show you real quick what do I mean by all of that, right? So I said, so there's this. So this guide here is how to do that using IAR. And then, as I said, we get a basic working sample, and then we add, in this case here, as you can see here, the PX5 files. In this case, we're using object files. It's already compiled for that platform. But of course, if you have, an NDA agreement signed, you can get access to the full source code. And then we start modifying files, right? So the first one we change is the startup file, and we do that because what PX5RTOS does is elevating main to the first system thread. And because how the way in which both STM and IR do with their tooling, that means that we need to create an extra processing stack pointer so we can elevate that first thread to that main to the first system thread. So this is pretty much all the changes you need to do in the startup file. Then we modify the linker file. Then again, of course, we need to do that for the new process stack that we created. And then we modify the interrupt file, because in this case, we're not going to be using, the internal interrupt anymore. So we do have a proper one from PX5 RTOS. So we have this interrupt process. So it's just a call that we need to add to it within this file. And then we modify the main to call that newest function that we created. And then we just add the header files, and voila, it's working. So you see, there are a couple of files, a couple of steps, but they're thoroughly documented. So this is something you should be looking for when thinking about porting an RTOS to a different platform. And then following, we have, well, more to think about, right? So when we're thinking about samples, there's feature samples, so samples showing how to do threads, queues, mutexes, semaphore signaling. you know the drill, right? All of the basic things that we need to do in an RTOS, but also you might be looking for more advanced samples, things like networking and IoT or both. So if you look at one of the samples that we have for an IoT, and that's for AWS, what we have here is then, of course, hardware. On top of hardware, we have kernel or PX5 RTOS. And then on top of that, we need PX5 net, which takes care of, all of the IP, TCP, UDP, BSD sockets, packet management, DHCP, DNS, all of the things regarding, the network stack. But also because we don't want to reinvent the wheel, because this is an IoT sample, we need an MQTT client. In this case, we use PAHO, right, for all things connecting, publishing, subscribing, serialization, and all of that. And also, because this requires security, so we use embed TLS for all of the crypto libraries, SSL, TLS, and X509 certificates. And then on top of all of this stack, then we have the IoT sample code. So as you can see here, this is an advanced sample, and it can be pretty tricky if you don't have the proper components to use and to leverage when you're running that sample, right? But of course, there's more you can do via things like artifacts like adaptation layers. So the one thing that I'll be showing you later today also is, because that's super cool, is the fact that, of course, this is the link to the ThreadX project, and this is the link for the GitHub repo for ThreadX. And as you can see here, ThreadX, so as this part here shows, right? So this is the kernel, but there's much more to it than the kernel, right? We have NetX Duo, which is, everything regarding to the networking. And then we have FileX, of course, as you can see here, is to work with files. GUIX and GUIX Studio to help you create, graphical user interfaces, USB, and even a tracing tool, for you to debugging solutions. So all of these exist here in different repos, which means anyone can use one or the other or all of them. And if we look back here, what we did at PX5 was to take advantage of GUIX, FileX, USBX, and even NetX Duo, and through an adaptation layer, make those available to PX5 RTOS. So just like we did, reusing these open source components, you should be looking to which are the components I need, and is it possible to do something like this for your solution as well? So there's a plenty of opportunities and plenty, of good quality open source code out there for you to use. And then finally, we're looking at training. And this is probably the hardest part, because if your user don't know your product or can't use your product, then there will be no adoption, right? So talking to experienced users, so using the experienced route here is normally easier because they know what they're doing. So looking here, they might be using IR or some, trivializer tools. They might be even leveraging hardware to do debugging and testing, oscilloscope, logic analyzer, JLinks, and all of that. So this is the experience route. It's easier when you're talking to a customer that knows stuff. They know how to do this. But we can't really, ignore a novice, or any rookies in this area, because, they might be your user tomorrow. So how do we help these people, these engineers that are taking RTOS and, they want to take their first step? Well, the solution is to make it insanely easy and insanely simple for them to see those concepts. And at PX5 RTOS, we use this thing called animation framework. So we have an animation framework to do training. And if you're thinking, okay, so which tool do you use to make this animation framework? Well, I happen to use PowerPoint, and we're using PowerPoint to show threads to show code, actual code, not pseudocode, and we're showing thread priorities, thread status, variables. We're showing, different status, and it is pretty cool. It's hard to create and it is hard to maintain. So there's no free lunch, right? But it's hard to beat in terms of simplicity and how easy it is to understand all of these concepts when you started. And here comes with a confession, because when I started working with an RTOS, it's been a long since I left college. I could not remember most of these things, semaphores, how they work, threads, and how do I work with threads, and how do I work with mutexes, and all of that. These can be tricky if it's been long time that since you work with that. So working and creating these videos have also helped me, to remember a lot of those things. So let me show you a quick demo of how to do this type of, oh, but now, how are we time? I need five more
It's
minutes.
fine, Wellington. Even if you're like few minutes over,
Okay,
that's totally fine. Yep.
all
Go ahead.
right, cool, thank you. All right, so I'm gonna show you how this animation framework works. And in the scenario I'll be working, we have two threads. We have a shared resource. In this case, it's just a variable, but you know how these things work, right? When I have two threads, they need to work with the shared resource, then we need to control access to that shared resource. Otherwise, you see a bunch of problems, right? And in this scenario, we solve for two threads trying to access this variable or this shared resource. At the same time, we're going to be solving that with a mutex. Okay, let's take a look how this works. So again, here we're using real code. There's no pseudocode here. I'm taking this code from the samples and I'm putting them into the animation framework. And you see here, we have main, and there's this blue glow. That means this is the active thread or the code that is running now. And what we have here in blue is the next instruction to be executed. Okay, so right now, all we have is, a bunch of creating variables, shared resources, and handles for the threads. Then the next line that will be executed is this one here that will actually be starting PX5 RTOS. So as you can see here, I have the call to the PX5 pthread start API. For that, I'm providing a random number for pointer data verification, the memory area, and the size of that memory area. I also have, as you can see here, two variables, a main thread counter, and I have the shared resource. Remember, the one that both threads will try to use. And then next, okay, so now I have pthread, I have PX5 RTOS started. As I told you, main is now a thread, so it's a main thread. It is actually executing right now. So next step, we're going to be creating a mutex. There you go. Here is the mutex. As you can see here, the name is mutex. There's no owner, and the mutex is not locked. Next, we're going to be creating another thread. There you go. Now we have the child thread created. Is the same priority as main thread, priority 16. That's standard. Of course, you can change that if you need. A main thread is still executing, and child thread is ready to execute. It's ready and waiting for its opportunity to run, right? So next year, main thread will yield, so schedule yield. And when it does that, it is now in ready state. And now we're running child thread. What it does is updates its counter. So you see here, the counter is now 1. It will try to lock the mutex. Mutex is free, so this should work fine. All right, you see here, it's locked now, and the owner is child thread. Now, child thread can actually update the shared resource, and it's going to be updating the shared resource to 2. Let's see. All right, it's done. And now it's asking, so the child thread will sleep. So see here, we're calling to the tick sleep for 1 clock cycle. And then it's blocked because it's now sleeping, and main thread is executing again. All right, it wants to update its own counter, and we'll try to lock the mutex. Well, we know what's going to happen, right? Because the mutex is already locked. So what happens now is main thread is also blocked, waiting for the mutex. But hey, look, now I'm also showing that the mutex is locked, its owner is child thread, and there is a waiting line here. In this case, internally, what we have here is what we have here is a structure that is holding all of the waiting threads for this resource, right? And I'm showing here the main thread is waiting for it. Now we have both blocked because this one is waiting on the timer. So when the timer interrupt happens, it is now unblocking this thread that is now able to run again. It's updating the shared resource from 2 to 0 again and unlocking the mutex. So you see here now the mutex still locked. Wait, what happened? Well, main thread was waiting. So by the moment, the instant, the child thread unlocked the mutex, it's already locked, and now its owner is the main thread. So what happens now is, as soon as the child thread tries to lock the mutex again, we know what happens. It's now blocked and it's waiting, and now the main thread is executing again, and it can run again. That's the example. So you see here, what we're talking about is something that I could show, with boxes and arrows in a PowerPoint presentation, and talking about how both threads are trying to access the same resource and they're competing for it. And there's value to that, but nothing beats you seeing actual code running. And this is the same code again from the sample. So if you take IR and you run this, it will work, right? And also, so we can show some of the things that you can actually see, but that are trickier to see. So things like all of this information here, this information is on the thread control. Actually, this is on the mutex in the control block. So this is all of the information that is not, easily viewable. So you need to dig a little before you can see all of this information. But hey, when we do this, we make it easier for our customers to see how our code works. But you know what? If you're looking to learn a bit more, about all of these internals from an RTOS or any RTOS for that matter, I would recommend you taking a look at some of the videos I created as well, because just like this one for Mutex, I have plenty more, so that might be an interesting, call to action, if I may, is to, taking a look. So taking a look at, well, the announcement for, ThreadX. Again, ThreadX is amazing and is now open source. So make sure to look at that, you know, uh, for a bunch of these devices, and, that you want to look. So, PX5 is also a very good option for you. And we have samples for a bunch of different boards. The videos I was talking to you about are in this channel. And as you can see here, I have thread, multiple thread, mutex, timers, message queue, semaphore, you name it. We have them all here. Even, some others that are perhaps a bit more advanced, like memory management, pthread lifecycle, IoT sample, and things like that. But also, if you're looking at, ThreadX RTOS, there's a bunch of nice videos. I would recommend looking at this guy here, this PR Tech Talk. He's making some pretty good, entry level embedded videos. And he started some of these videos for, ThreadX. He mentions as Azure, but Azure has nothing to do with it anymore. So this might also be a good place for you to get started.
That is
Okay,
awesome. I was wondering, like,
that's it.
for a novice in RTOS, like, where do you say, like, to start, looking at running the samples or playing with RTOS in reality?
If you're a novice and you have no experience at all, I would say YouTube has pretty good content and some nice series. But before you getting into YouTube and figuring out what to do, and which of the RTOSs you're going to be looking, is making that decision of, okay, which one, right? Again, if you're looking at the the most widely used, then of course FreeRTOS is a no-brainer. You will find tons of information regarding FreeRTOS. Now, if your company already uses a different one, then look for that one, right? Now, I would also encourage folks to take a look, and then you see me going back, to ThreadX a lot, just because, yeah, I like this project a lot. And there is here in the repo, you'll find this getting started. So there's samples, but the getting started guides are really awesome, and they're ported to a bunch of different devices, and they will help you end to end, on how to get the devices there. Of course, this was created back in the day when we're all at Microsoft, so they're all built to work with Azure, and Microsoft IoT. You can ignore all of that, because if you get this running on your device, you already have what the most important bits, which is have the RTOS working for your platform, and you have it running, right? So I would recommend doing that.
Yeah. Any questions, folks? Do you want to ask?
Oh, I,
Demos
I'm
are always great.
yeah, I'm thinking of another thing, which is again, right? If you study, in college for all of that, then you might remember. If not, if it's been a long time since you ever did any of these, I would also recommend, this book. Okay, the P-Thread. This is a classic, right?
Yeah,
Oh
yeah,
my goodness, yeah. If I can, so the P-Thread programming from O'Reilly. This is a classic. This is super useful. I use this thing to this day, every time I need to look at some of the APIs and trying to remember how, POSIX was doing the one thing one way or the other. So I would really recommend reading this book or taking a look at that. But also, going back to basics is always good, right? So if I would go back to, my videos, and you can skip if you don't ever want to use PX5 or TOS. That's fine. You may skip all of the parts that are specific to that, but take a look, at the animation framework, because the way we do at PX5 or TOS is pretty much the way any other RTOS would work. So when we're talking about threads and multiple threads and using mutexes and message queues, oh my God, memory unlock and free, condition variables. So this is all, all our tosses out there have all of these, So if you look at this video and you understand how we're doing here, it's the theory you might need, so you can go ahead and jump to, whichever other RTOS you have and understand what they're doing, right? So taking a look here won't hurt you.
yeah. Is the hardwares which are compatible um, already like on the website, or like where do we
Oh,
find
yeah. If
that?
you're running, yeah, all you need to do to get, a sample of this working is just to log in. You give your email and you're fine. And you get to download the samples. you know I personally have a bunch of these, the L4 plus U5, there is the Nucleo C0, which is pretty good, I must say. It is a tiny, M0 that is amazing. I love it. The U5 is a bit beefier. There's the G series, there's the Age series, and it's a bunch of the F769, which is, a classic, right? I mean, I've been using this for a long time. And then, but there are samples for these boards, for some Texas boards, and Renaissance, and even, so you saw the Sci-Fi and Giga devices. And if you're into, the Cortex A more advanced level and you want to see SMP and AMP, in action, there's actually, some of these Xilinx boards as well with samples for them. So, you know, it won't hurt to get a download, to download and give, this a shot. We have samples that are already working. And then if your company is not up to buying licenses, or you for your startup can afford a license, at least you learned something, and then you can jump to the next best thing. In my mind, ThreadX, and then work from there.
Yeah. Um, I mean, we had one workshop on Walkme simulator, if you
Oh
know
yeah,
about
yeah,
that.
yeah.
And they have a library to support free RTOS. So there are some samples that you can run with free RTOS on Walkme, which is pretty cool that you won't need like hardware as such, and you can still kind of try out things and see how it works. Uh, yeah.
I agree. I agree. Well, that's a good point. For most of these samples, you can run them without hardware. They're simulators, especially if you're using if you're leveraging IAR. Then, so you see here there are samples that are for IAR,
Mm.
and some samples, like, of course, if you're using an XP, then you have their own IDE instead, right? Or for Renaissance, that's the same. And then, of course, for ST, then there's the QBID, right? So we have samples for both, but these samples also work with simulation, uh, which is good for you to get started. But I don't know, no. I don't like simulators. I like
Mm.
hardware. The more, the better. If you don't know which one to get one of these C0s. They're really cheap. You can get a device like this for $20, you know, $20. And you have the hardware to test, and you have the ability to have, of course, the LED blinking, because you can never have enough LEDs blinking around. But then you can, you know bring additional sensors, bring additional, hardware to connect to this hardware. So I don't know, I kind of love seeing things happening in the real world. I think the beauty of embedded is exactly that, right? When you combine software world with hardware world. So I can imagine myself doing this without having, the hardware. So don't get me wrong. I love Walkly. I love their simulation. But yeah, I would prefer working with real hardware all the time.
Yeah.
Yeah.
Chris or Akil, any questions?
Oh yeah, and just for folks to know, I posted here on the chat the links for all the things I showed.
Oh yeah, thank
So
you.
yeah, yeah, it makes it easier for them to look after.
Hi, Wellington. I'm Akil. I'm also a embedded software engineer. I'm currently unemployed, but I'm looking for a job. And I like coming to these meetups to learn more about what's going on
Of course.
in the tech field. And so I'm pretty young in my career, but I've mostly worked with bare metal and free RTOS up until this point. So one question I have is, what makes PX5 distinct compared to all these other RTOSs? You mentioned a lot of reasons based on, the feature sets,
Hmm.
compatibility with other hardware devices, and certification. So,
Yeah.
what's unique about PX5 in this case?
Well, it's interesting because lately it's getting harder and harder to see uh, the RTOSs out there that are functional certified. So that's definitely a plus, as you saw. Uh, all of the documentation and all of the questions about, support. How can I work with this later? And how hard it is to get started. So we're trying to, make it easier to adopt. It is definitely, a better version of every other RTOS that was created by the founder. In this case, that's Bill Lamy, right? He was the one. This is actually his fifth RTOS, right? So the previous one was, ThreadX, So this is an evolution of that. So it's evolving, right? It's an ever evolving solution. It's insanely tiny. It can be insanely tiny, and faster than most RTOSs out there. I don't have a benchmark to show, so I don't want to talk, top of my mind, but it is insanely fast and it is insanely tiny. That's why I'm saying that, if you have any of these devices and you want to see for yourself, it's free. Just go ahead and download it and, give it a try. It won't hurt. At least you'll learn a bit extra, right? And as much as I know, and I keep saying that, and I have a slide showing that FreeRTOS is the top one in terms of adoption, right? It doesn't hurt knowing a different one, right? And then again, especially if you have the time and the opportunity to look, at ThreadX, right? It's well, think of that. Microsoft wouldn't have bought, for I don't know how many millions, so I'm not getting into that, right? So they paid good money, to buy ThreadX. They did that, and then they put a lot of resources. The team was big. I don't know if I can share that information or not, but anyway, there was a bunch of very good engineers working on this product for multiple years, 3 or more years. So it is, a pretty nice product. So I would say, take a look at this. It's free, it's open, it's easy.
Why did Microsoft decide to make Azure RTOS open source? Is there any particular reason behind it?
Oh, I, I don't know. The decision was made after I left the company. So there's a bunch of decisions coming from top down regarding the IoT organization, and
Hmm.
perhaps they decided that this microcontroller world or the device world was not a place where they wanted to be. Well, given that they gave up Nokia, right, and all the phone business, when you left the phone business behind, leaving the microcontroller business behind, it will be easy, I guess. you know so they decided that this wouldn't be a good thing for them, and then they made the transition to the Eclipse foundation, right? So it's there. It's pretty cool. I hope it picks up. Of course, we know FreeRTOS is what it is because of the community, right? Because of so many people using, so many people trying, so many people getting in trouble and helping each other. It's the power of the community that makes FreeRTOS as as popular as it is. So I really hope to see ThreadX getting the same traction, getting the same amount of people looking at it, trying it, and realizing that, oh, okay, there's some good stuff here, you know, and learning a bit more about that as well. Right. So yeah, if you take the time to run the Blinky, you know, uh, sample from these things, you're going to be learning how different RTOSs are tackling the same problem, right? Not to make any uh, judgment here of which one is good or bad, but at least you will have a better understanding of different RTOSs, and that can't hurt in an interview, right? When you
Hmm.
go like, oh yeah, I saw this one does that and this one does differently, and talking about that.
So going off of that, how would you make the decision as to which RTOS you should be using for a particular product or project? If
Hmm.
there so many of them have different trade-offs and benefits, how do you go about deciding which one's the best one
Yeah,
to go, whether it be for and also considering like if you're putting these products to scale and you're trying to sell multiple of them, and you also have to
of
provide
course,
support. So,
of course.
what decisions go through your mind when thinking about that?
Well, it's a bunch of what I said throughout the presentation today, right? So if I can go
Mm,
back to this one slide, I think this one sums up pretty well, right? In terms of what are the features you're looking to get, right? And this one is not crazy because most RTOSs have them all, right? But if you need functional certifications or not, then you narrow down the list, right? Which sort of compatibility you need, if you're willing to pay for royalties or not, if you need, eventually it's a startup and you don't need support and you can't pay, or oh yeah, it's not a startup and that we kind of have money to invest, in something beefier, then you go, or any differentiators like size and, memory and speed and all of that. So I think this is a good summary of the things you need to consider, right, for your application, right? And then as you're looking to your application and listing them and, looking at the trade-offs, then, you can easily go like, oh, functional certification is a must. Then you can really use free RTOS. There's safe RTOS, which is a certified, you know, branch of RTOS, flavor of RTOS and free RTOS, but then, you go from there. Make sense?
Yeah, makes sense.
Yeah. It's not easy though.
Yeah.
It's not
And
easy though.
you also mentioned that there was a simulator, which walkway you mentioned. Did I say that correct? I just want to note it for future reference.
Yeah, that was me. I'll type it in chat. Yeah, it's walking. Yeah.
Thank you.
We did a meetup on this
It's
I
this
think a
guy
couple
here,
of
right?
months back. So I'll post a link to that as well if you're interested in looking at the recording.
Okay, thank you. Yeah, that's all the questions I've had.
Cool.
Thank you so much, Wellington.
Sorry?
Thank you so much.
Of course.
Very
Yeah. It was a pleasure being here. If you have questions, you know where to find me. I also left the link here to, not the link, my email address. So let me, sorry, go back here. This www at px5rtos.com. So if you have any, additional questions or comments or anything like that, just let me know.
awesome. Yeah.
Cool.
Something different for our meetups. So was looking forward to this. Yeah.
Of
And
course.
thanks for spending time in kind of like your night time zone.
Yeah. Yeah. Well, if in the future you need to, you want or you find people asking to, dive deeper into any of these, I'll be glad to come back, and talk a bit more about all of these. There are a couple of things I want to test for myself and might be interesting to do a live demo here. So
That would be
things like,
yeah.
yeah, things like, I want to do some benchmarking and see, speed and things like that, but I want to do it the hard way. I don't want to do speed tests by trusting IDEs. I want to do speed testing by, getting a logic analyzer and flipping, a bit on a pen, and measuring that and then seeing, how fast I can do context switching in different RTOSes, how fast I can create an object or not, and to see that happening, using different RTOSes. So maybe that's something cool to show here as well.
Yeah.
Anyway, that's a topic for a different day.
We'll do a poll for that next time. So
Deal.
awesome.
Deal.
All right. I think we can end the session if nobody has any other further questions.
Nice. I hope to see more of these online meetings, Binal. I'll be glad to join future versions of it, as long as they're online. So it makes it
Yeah.
easier for me. Yeah, glad
Sure.
to participate and help in any way I can.
Yeah. Thank you so much. Thanks for that feedback. And I hope to do some more, at least hybrid, if not just virtual.
Oh yeah. Oh
Yeah.
yeah. Hybrid should work too.
Yes.
Cool.
Thank you very much, Wellington. It was a great presentation.
Of course. Thank you.